Coming up next on Arizona Horizon, we'll hear from the head of the state's elections department on yesterday's Supreme Court ruling striking down part of an Arizona voter registration law. And ASU physicist Lawrence Krauss joins us for our monthly update of science news. Those stories next on Arizona Horizon.
Arizona Horizon is made possible by contributions from the Friends of Eight, members of your Arizona PBS station. Thank you.
Good evening and welcome to Arizona Horizon. I'm Ted Simons. The U.S. Supreme Court yesterday struck down part of an Arizona voter registration law. The court held that Arizona can require proof of citizenship when registering to vote using a state form, but that same proof of citizenship is not required when using a federal form. Arizona Secretary of State Ken Bennett, the head of elections for Arizona, is here to discuss the impact of the ruling. Good to see you again.
You too, Ted.
What are your thoughts on this ruling?
Well, we were disappointed that the Supreme Court did not rule directly that Arizona could do what we're trying to do. But the more we've read the case, the more we realize that they really outlined how to resolve this issue, and that is go over to the Federal Elections Assistance Commission and ask them for permission to add these requirements that Arizona voters said that they wanted to have implemented in Arizona to the state-by-state instructions that come with the federal form. So I think we eventually will get to where we wanted to be, but the Supreme Court kind of decided that they weren't going to grant that relief themselves. They said, go over here, and then if they don't give you what you want, then you probably
come on back.
You can come on back.
Yeah.
I think a lot of courts usually want you to exhaust all your administrative remedies before coming to them and ask them to finally make an order.
Before we get to those, and there's another option out there that I don't think you're quite as excited about, but I want to talk about that as well. But why should Arizona be involved in federal voting requirements?
Well, the federal Constitution clearly says that the states get to decide what the requirements for becoming a voter in that state are. And every state, in one form or another, has adopted the voting requirements. In Arizona, the citizens said back in 2004 that we want to verify citizenship when a voter registers to vote, and then when you get to the polls, we want to show ID and things like that. So the Constitution allows states to identify what the requirements of being an eligible voter are, age or whatever it might be, residency in the state, in Arizona's case, proving citizenship.
But the courts seem to say that's unless the federal government says this is the way you register to vote.
Well, then the courts also say that, yes, we allow the states to decide who gets to vote, but we have some say in how federal elections are run.
Indeed.
And if candidates for federal offices are on a ballot, the federal government is going to weigh in certain ways to make sure that those elections are conducted in accordance with what they believe are standard minimum requirements, and how you conduct the election, they don't want you to go beyond what their requirements are. But as far as who gets to register to vote, in fact, they said that the power to establish voting requirements would be meaningless unless the states had the power to enforce those requirements, and therefore it would be unconstitutional. They said it would be unconstitutional for the federal government to tell Arizona ultimately that we can't have the ability to verify a person's citizenship if that's the law of our state.
But when it comes to federal elections, again, kind of a different ballgame with that in mind. There's some thought out there that the state should go ahead and enact some kind of law in which you want to register by federal and use that postcard, the federal form, go ahead, you can only vote in a federal election. Register state, proof of citizenship, you can vote the whole 9 yards, or at least state-owned. Is that viable?
Well, the counties, and I've talked to all of them in a conference call as recently as yesterday, that would set up this bifurcated set of elections where if you've registered one way, you can vote in all state and local elections, including the federal races. But if you've registered this other way and hadn't proven citizenship, then you can only register and vote in the federal races. That would be a nightmare, I'm told, by all of the 15 counties in trying to keep this duplicated or bifurcated system of elections. So I don't think that's the way we want to go down. I think, as the court told us in the case, they said go down to the Federal Elections Assistance Commission, which has existed for 10 or so years, ask them to put this requirement in their state-by-state instructions that they provide. And then if they do, then we got what we wanted. If they don't, then come back to us and say, and ask if maybe we need to force them to do that.
But didn't the state previously ask for this and the commission voted 2-2 and so
Yes.
nothing changed?
We asked back in 06 or 07 for this requirement to be put in after the voters of Arizona passed Prop 200. The commission had 2 Republicans, 2 Democrats on the commission at the time. They deadlocked 2-2. And the Attorney General at the time, Mr. Goddard, chose not to appeal it. And essentially, I think what the court said today is they don't really think that the commission can deny that. And so I've already signed the letter as of today to send a re-application back to the EAC. And even though they don't have any commissioners...
I was going to say, who's on the commission? No one's been approved. I mean...
during the Obama administration, there have been no commissioners appointed to a...
Well, I think the confirmation process is the problem there, isn't it?
It could be. No, I don't think he's even nominated any commissioners to fill the seats on this commission. However, the state of Louisiana submitted an application similar to Arizona's. They had something in their voter registration process where they wanted additional information from the voter to be attached to the federal form, and that got approved just last year by the acting director of this commission, even though there's no commissioners. So if they've approved for Louisiana requiring voters to provide additional information to comply with their laws, we think that we have a good chance that they'll do the same for Arizona.
And again, Justice Scalia basically said, if they don't, come on back and try again, which is interesting in that.
Yeah.
Last question here, and kind of a different look at this. We will continue to look for ways to ensure only eligible citizens are casting ballots. I think that was a quote from you. Why is this necessary? I mean, how many incidents have we seen of non-eligible citizens casting ballots?
Well, what we have seen is we have, in comparing voter data with other states, we have found people voting twice in states in the same election. They're voting in Arizona and in other states at the same time. We have counties that receive hundreds of jury questionnaire forms every month from voters who say, I'm not a citizen of the United States, therefore I don't have to serve on a jury. But then they take them over to the voter registration database and find that they checked the opposite box saying, yes, I was a citizen of the United States when I registered to vote. The incidence of illegals voting might be a few, but we don't want any. And if we had any policy or procedure in Arizona that turned away one legitimate voter, people would go bananas, as they should.
But
any illegitimate vote cancels out a legitimate vote, and so we want to make sure that everyone that votes is legitimate.
But real quickly, the critics will say minorities, elderly, the students are often those who have to go an extra yard because of proof of citizenship and identification. You may be denying, if not necessarily de facto denying their participation.
But that's why we have provisional ballots and all kinds of procedures so that if you show up at the polls and want to vote, you get to cast a ballot. And you have so many days to come back and show that you are who you are and you reside here and you're a citizen. And those are in place to make sure that everyone who is legitimate gets to vote. But we don't want illegitimate votes canceling them out either.
Good to have you here. Thanks for joining us.
All righty.
ASU physicist and best-selling science writer Lawrence Krauss appears on Arizona Horizon each month to discuss the latest in science news. And tonight, we touch on black holes, mass extinction, and apparent toboggan marks on Mars. Here now is ASU physicist Lawrence Krauss. Good to see you again. Thanks for joining us.
It's great to be here in cool Arizona.
All right, speaking of cool and climate and stuff,
yeah, exactly.
There's new information on what 12,000 some odd years ago something may have hit or came close to hitting and did also. What's this new information?
Well, the new information is studying below the surface of the Earth rocks and discovering evidence that rocks melted, not just here, not just in North America, but at several places around the world, producing what are called these carbon spherules that really only happen if there's extreme heat, suggesting that a comet or some large object either hit the Earth or came close enough to the Earth to produce enough heat to melt a lot of rocks. Now, what's interesting about that is there were a lot of extinctions around then, woolly mammoths and other things, but the claim that's being made is that it wasn't a comet impact itself that killed these things, but climate change that occurred after it. You know, when there are large volcanoes on Earth, the climate changes. And in fact, people have talked about nuclear winter. We can talk about that. Whenever there's a lot of particulate matter thrown up in the atmosphere, that blocks the sun. And has been known in the case of Krakatoa and in fact, even earlier, a volcano in 1815, in many places produced summers that felt like winters. And so the argument is that these spherules, which are seen in 4 different continents, which say something happened to heat up rock enough to melt it, also threw up enough stuff in the atmosphere, 10 million tons or some large amount, I forget the exact number.
I think that's what it was.
And, that it actually blocked sunlight enough that changed. If you look at the heating, there was a glacial period. It was getting warmer, and then suddenly, for a little while, it got colder for a century or so. And the argument is that the material thrown up in the atmosphere made it colder, and a lot of animals didn't survive. And the interesting thing is, people were around then too.
Yes, apparently we were,
yeah.
And we did survive while the woolly mammoth shuffled off the mortal coil. Now, so comet either hits or does something and melts rock, and spherules are here the whole night. Why does all that stuff going into the air mean severe climate change for 100 years? Can't we get rid of that? Doesn't the wind blow? What's happening?
Well, the circulation time to completely get rid of stuff can be many years. And in fact, the interesting thing is, there was a recent study in a related vein which should concern us because, in fact, on a totally different vein in some sense, that India and Pakistan have both increased their nuclear arsenals. A study about 5 years ago by some physicists showed that even a small nuclear war between India and 100 nuclear weapons, would produce enough stuff in the atmosphere that for a decade there'd be climate change, and in fact 1 billion people would die of starvation because of it around the world. The material stays in the atmosphere for decades, especially when it's small. And in this case, apparently there was a cold spell for 100 years. And I think the fact that humans live through it is a very interesting thing, because it points out that actually my colleague Curtis Marion and others have studied a cave in South Africa where humans occupied for almost 100,000 years. And during that time, there was incredible climate change. The ocean receded by 5 miles, came back, and humans have had to evolve. We are used to thinking, in fact, many people don't even realize, of course, that we're producing climate change right now. But independent of human-induced climate change, over a period of centuries, there's natural climate change, and you have to be able to adapt to it, or like the woolly mammoths, your history.
Well, and again, the researchers that were here said we basically had 3 options for life on Earth. You could either relocate, you could either downsize, or die. We must have done one of the first 2.
And if you look over human history, the migrations have indicated that humans have in fact adapted very well, and having a brain helps. Having a brain that allows you to plan is really important. In fact, you know, the chicken and egg is an interesting question, but this fish diet, for example, in South Africa had high protein, which probably helped in brain development, which meant that people could adapt to changing environments, to changing food environments. Whereas if you can't do that, if your entire existence consists of looking for a certain type of food, and that type of food goes away, well,
Yes.
I was going to say you're cooked, but in
Yes.
this case you're frozen.
Yeah. The researchers again call this the last gasp of the last ice age. And you were saying how the temperature. So what is the normal Earth temperature? Or is there
Well,
a normal Earth?
it varies over geological time and has varied. And there are cycles. There are well-known cycles, Milanovich cycles. There are cycles over periods of normally thousands of years. But that can happen over centuries, where there are small variations. The Earth-Sun distance actually changes over time, and over millennia, you can have periodic changes in temperature. That's not what's happening right now. The change that's happening right now is happening over decades and is exactly correlated with carbon dioxide in the atmosphere. So it's a very, some people say, well, the Earth is getting hotter, but it's a natural phenomenon. It is true that there are natural cycles due to a variety of things, primarily the Earth-Sun distance, but other factors, which we're only now studying. But they happen over longer times. And there was an ice age, well before this 13,000 years, that had started to warm up over a period of several thousand years. And then there was this blip where things got cold again for a century or so. And that's where the certain set of animals weren't able to adapt. Because again, if things change over a long time, it gives a lot longer for things to adapt and evolve, basically, for natural selection to take place. But if there's a sudden change in a period that's short compared to biological time, then species can't evolve, or natural selection doesn't play as active a role. And whenever you have such a thing, you see a lot of extinctions. And we're producing mass extinctions right now that far exceed those that happened at that time. Mass extinction, the advent of human industrial activity has produced a bigger mass extinction than that did.
With that in mind, are there adaptability lessons from what happened 13,000 years ago that we could apply today?
Well, we're going to have to adapt. I mean, I think we're already seeing it in New York. As Mayor Bloomberg talked about new plans to be able to protect New York against new storms, because it's going to happen as sea levels rise and storms get stronger. So there's no doubt that climate change is not going to wipe out humans. But we have to adapt because, and in a complex society where small events can produce vast economic changes, we have to be prepared for these things. So we may not have a comet to worry about, although we may. Yeah. But we're doing a pretty good job on our own.
All right. We have apparent tracks on sand dunes on Mars. What's this all about?
Surfers, sand surfers.
Sand surfers. Not toboggan. I heard
yeah,
toboggan
they look
sliders.
like toboggan marks on Mars, and I'm sure it's one of the many things that some people think is for life. But what was interesting is you see these marks going down the dunes, and you wonder, are they streams of water? Because, of course, water's a thing, and we've talked about this before. Water's a thing we're looking for on Mars, because water, where there's liquid water, generically there seems to be life. But what's interesting is these toboggan runs sort of go down and then suddenly stop with a little indent. And that doesn't look like water. And what's really been kind of interesting is new studies have shown that it's probably dry ice, frozen carbon dioxide, that basically surfs down the sand dunes. Because carbon dioxide, you played with dry ice,
sure.
Probably. It's solid carbon dioxide. It freezes. It goes directly from a gas form to a solid form. It's something called sublimation, actually, the reverse, when it goes from a solid to a gas form. It doesn't go through liquid form at 110 degrees below 0 Fahrenheit. Okay? But you can get this stuff, and because it goes from solid to gas form, you put it on a surface, and as it starts to sublimate, it basically creates a cushion, just like those air hockey tables. You play air hockey. And so if you have a small block of carbon dioxide, it creates a little air hockey table below it and starts to slide down until it finally melts. And so those patterns seem to be evidence of carbon dioxide, which is interesting news, of course. It tells you that there's probably dry ice that is melting on the surface of Mars, but unfortunately, it also means that many of these surfer patterns or toboggan runs are not due to water, which is important if we want to know about life.
Could water still be somehow involved?
Well, there are some patterns on Mars that look like they were due to liquid. These aren't.
These aren't.
And I think, we have to, the great thing about science is we all want there to be water on Mars, but we have to be honest. And if these things aren't water, it just reduces one possibility. It'd be great to find life on Mars, but it may not be there. It may the conditions aren't there. And that's the great thing about science. We'll take what nature gives us, and we'll try and figure it out.
I think it'd be great to find air hockey on Mars.
Air hockey, yeah, exactly. Little games of air hockey.
Goodness gracious. Okay, so we've solved that particular, or they think they've solved that.
Yeah, it looks just like dry ice, and I was thinking we should have brought some dry ice in and played air hockey on the table, but anyway, maybe next time.
All right, something else, and I don't know how big a deal, we've talked about black holes a lot,
yeah.
And I don't know how big a deal this is, but it seems like some scientists are making a big deal. 26 new black holes found in the Andromeda galaxy. Why is everyone excited about this?
Well, I don't know whether everyone's excited, but black holes are fascinating, and the question is, there are big questions about how they form and when they form and how they're related to the formation of galaxies themselves. As we've talked about, pretty well every galaxy we know of appears to have a large black hole at its center. These are million or billion solar masses. In our galaxy, there's a million solar mass black hole, or what appears to be a million solar mass black hole in the center of the galaxy. Of course, we're inferring that it's a black hole in the case of our galaxy by seeing objects move around this spot where there's nothing, and they're moving so fast from their speed we can determine the mass of the object, and we find out it's a million solar masses, but it's so small that our physics calculations tell us it must be a black hole, namely something so dense that gravity can't, that light can't escape from it. But of course there can be black holes of many different sizes, and some stars, we calculate, when they die, they collapse, and they're not massive enough, so they collapse into what's called a neutron star. Everything starts to collapse in until it becomes one giant atom, essentially, one giant nucleus of an atom. At that density, it stops and reverberates and causes a supernova explosion, which produced all the material in my body. It all came from an exploding star. But if the star is massive enough, we can calculate that it won't stop there. It'll keep collapsing. Nothing can beat gravity and eventually become a black hole. And so what's interesting is, are there solar mass or 10 solar mass or 20 solar mass black holes? And you can look for them not by looking at objects orbiting them, but by watching material fall into them.
Yeah.
And because if material falls into a neutron star, it achieves a certain speed and emits a certain type of radiation. But if it collapses around a black hole, according to recent calculations, it gets near the speed of light. And it emits radiation, what are called hard X-rays, much more efficiently. And astronomers can try and look at the X-ray emission from objects that have a companion star, so that mass is falling into them all the time. They're called black hole binaries, and they can and by looking at the X-ray emission from these objects, you can try and say, is there a neutron star or a black hole there? And it's one way to say that maybe there are a lot more black holes in our galaxy than we thought.
So the way these black holes were found is the exciting part of the story.
Yeah, it's different ways to look for black holes, and of course a lot of it depends on theory, because you have to try and model what happens to gas as it falls in a black hole. And I think we're a long way from knowing that specifically. We'd like to know what the final stage is.
I always try to ask about a black hole because it boggles the mind. I once asked what's behind a black hole, which I thought was a question that was, I don't know if it's a good question or not. But here's another one. Is a black hole forever? Does that part of space just not exist? And what
is there a hole in space? It's a region of the universe that's separated from all the rest of the universe because nothing can get out of it.
Right.
And as I say, there are many different size black holes you can make. Some are more exotic than others. They're fascinating to think about something being that dense. They would be forever, except for something discovered by Stephen Hawking, who discovered that, and not that diamonds aren't forever, that black holes aren't forever. Amazingly, even though classically nothing can get out of a black hole, when you apply the laws of quantum mechanics to black holes, basically material can leak out of a black hole, and a black hole will evaporate. It'll get hotter and hotter and hotter, and black holes have a finite life. So if Stephen's right, then every black hole in the universe has a finite life. Now, a solar mass black hole will exist for trillions and trillions and trillions of years. A small one can evaporate in a minute or so.
Can there be a galaxy in a black hole?
Well, it could be that there is, in a sense, the amount of mass in some galaxies. We find billion solar mass black holes, or 10 billion solar mass black holes. That's almost the mass of a galaxy. So that much material has fallen in and is inside a black hole. And what happens at the very last stages, we don't know, because the laws of physics break down in the final stages of black hole collapse. Black hole physics is really at the forefront of our theoretical understanding of nature, which is why it interests people like me.
So we could be in a black hole right now and not know it?
Well, the whole universe could be a black hole.
Yes.
In fact, if the universe is closed, meaning there's enough matter to cause the universe to recollapse, then and if there weren't for this dark energy, we would be living inside of a black hole.
Lawrence, we will see you next. Let's talk about time next month. Can we do
if
that?
We have time. Let's talk about it.
Thanks for being here. Wednesday on Arizona Horizon, we'll have our final legislative update for 2013 with a roundtable of reporters from the Arizona Capital Times. And the monsoon officially started a few days ago, and ASU climatologists will preview the summer storm season. That's at 5:30 and 10 on the next Arizona Horizon. That is it for now. I'm Ted Simons. Thank you so much for joining us. You have a great evening.
Arizona Horizon is made possible by contributions from the Friends of 8, members of your Arizona PBS station. Thank you.